about introduction about Unix. Remember that our course will have two main parts. For the first half, we learned about Unix system, and then after that, we will learn about C programming. After you already have some fundamental knowledge about Linux, we will do a more advanced programming stuff on Unix system. So first, let's talk about the introduction about Unix. In this slide, we will adopt the original slide from Dr. Rao Shanderman and from Dr. Michael Wicks. We will discuss that, and originally this slide is from the Unix for Programmers and Users book. So let's begin. So because before we talk about operating system, let's talk about computer, the thing that run the operating system. So for the computer system, it will have two main parts, the hardware and the software. So roughly speaking, hardware is anything that you can touch. It's called hardware, like the central processing unit, the memory, disk drives, CD-ROM drives, monitors, USB drives, graphic card, keyboard, mouse, printer, and it can go to other peripheral device like that. Maybe you somehow know that, like the modem to help you to connect to the internet, the Ethernet interface which allow you to connect to, for example, the wireless system, or maybe the other interface for you to connect to the printer, or even the cable, USB cable to connect to your phone, smartphone. They are all the hardware. And for the tape drive, in a very old system, they will have something like a tape which acts just like your hard drive to store your file, but the tape is a very inconvenient way to store data. And nowadays we almost don't use the tape drive or CD-ROM drives anymore. And for software, is a program that run on the hardware system. So the first thing we can talk about software is like the operating system, which is a fundamental software to manage your hardware. And then after that we can talk about the application programs. The application programs, there are tons of them and you interact with them every day. So for example, you use a web browser like Chrome, Firefox. You may be using the word processing, a Excel, spreadsheet program. They are all application programs to serve some purpose. And among the operating system, then Unix is the name of a popular operating system. Now, even though we say it's a popular, nowadays actually the most popular one should be Windows, and after that is Mac. But Unix is a kind of operating system that have a very old roots. And nowadays we have some new operating system that stem from Unix. So you can say Mac is a type of Unix, and Ubuntu is a type of Unix operating system. So if we say about Unix, we talk about a family of operating system, and actually it is very popular. So let's talk about a typical personal computer system. Why personal? Because the personal computer system is the one that you use it, you interact with it every day. It is a lightweight, maybe portable. It is a commercial product that is very popular. So let's talk about this one. A personal computer system or a PC, they will have some basic component like CPU and memory. This is a central component. As you can see in the figure, it is right in the center and they have a lot of arrows to connect with it. That means that a system must have a CPU and memory to run, and that's it. Only CPU and memory is enough for the system to exist. Now, it may have some other hardware devices to make it easier to work, but not necessarily needed. So a system may not need a hard disk, a system may not need a monitor, a system don't need a mouse to run. It still exists and it's a computer. But you cannot remove a CPU, you cannot remove the memory. Remove one of these two and this is no longer a runnable computer system. Then the core part will interact with all the peripheral device via an I/O interface. I/O means input and output interface. That means that if a monitor wants to interact with a central core system, it will send some signal and it will go through the I/O interface and the signal will be go to the CPU and memory. The same for any other devices like keyboard, a Ethernet communication interface, floppy disk, drive, printer, and so on. So we talk about personal computer system. So how about the other like server computer system? So for example, a server, they may not need a monitor, they may not need a keyboard or a mouse, but they can still run. So for the server, maybe they have a system like this connect to some a network interface like Ethernet interface, and that's it. And then you can connect with the server system via another machine, and you go through this communication interface to interact with the system. That is another example. So let's talk about the key component of any computer system, not just PC, but also other non-personal system. That is the central processing unit and the main memory. So the central processing unit will do all the calculation like mathematical calculation or logical calculation and stuff. And main memory is something that it needs to store the data. So again, in the central processing unit, it will have a chip to execute the command, the program command. So for example, 1 plus 1, it will execute a plus. And for example, one example of the central processing unit is you have the Intel Pentium 4, which is like 10 years ago. And now we have a much modern Intel processing unit, but the principle is again the same. Then we have a primary storage to store all the data that needed to be used. So for example, you do 1 plus 1, then 1 and 1 will be stored in the main memory, and then we will transfer the 1 into central processing unit. And central processing unit can calculate 1 plus 1 is 2, and it drive back 2 to main memory. So that is just a typical way for the key component to work. Again, is the main memory will have multiple types of memory. It will have something like a register, which is a really fast memory, but its capacity is super tiny. And then it will have something a little bit bigger, but a little bit slower. It's called cache. And then finally we have something called a random access memory, which is huge. It can go like to 8 gig, 32 gig, or so on. It's really huge, but access the RAM is slower than other type of memory. So again, for the main memory, it's an aggregation of multiple types of memory, including the RAM. Now let's talk about a secondary memory devices. That is these things are not needed for the system to exist, but it's really needed to work. It's called a secondary memory devices. So the central component here is can be connected to either hard disk or a floppy disk. Well, for nowadays we don't use floppy disks anymore, but we use other things like the USB disk and hard disks or so on. It's called secondary because it store a long-term storage, and because it is a long term, it is much slower, but it is permanent. And memory cannot store something permanent. So if the power go off, everything in memory will be erased, and you need to something to permanently store it. That's why you have the hard disk. But hard disk is slow and it is much bigger than memory. So one example of usage is like this. For example, you run Windows OS on your machine. So the OS system will store on hard disk. Whenever you push the power button, then the hard disk, a portion of the OS on hard disk will be transferred to memory, and then the central processing unit will interpret the command in the main memory and the data, associated data, and it will process it and write the result back to main memory, and so on. Now we need another kind of component in order to work. Again, it's not it is not a thing that make the system exist, but it's really needed to work. It's for the input and output device, we have a monitor and keyboard. So the keyboard is your standard input. You input everything from human via keyboard, and the monitor is output to human to read it. So other that maybe not necessarily needed, like joystick, barcode scanner, touchscreen. These things are not a standard input or output, but it can also be used to give data to the central processing unit. So for example, when you are using operating system and you typically suddenly you receive an error message, like so for example, um, just example like it's asked like you need an administration permission to do this action. Do you want to do it, yes or no? So this information will be given to you via monitor for you to read it, and then for example you can click a mouse button, or you can click on the keyboard, and then the signal will be sent to the CPU, and the CPU will continue running the program. That is a typical example of the usage of input and output devices. Now let's talk about a wider scope. So we have a multiple computer system interact with each other, and then it will be called a computer network. So let's talk about a local area network. So for example, in your house, you have a modem connected to the internet, but the modem also help you to connect multiple machines together. So for example, you have your personal computer PC, you have your smartphone, and maybe your TV. They are all connected together. So for example, you can share a file from your smartphone to your computer via Wi-Fi, or you can use a smartphone to control the TV to change the channel. Everything will be done via the local area network, and typically the data will go to your modem, and the modem will transfer the data back to the other devices to receive the data. That is a LAN or local area network. Now, for example, if you need to access a iCollege on GSU, then you will need to go to the internet. That means you need to go to the modem, which is also called a router. It will access the router, and the router is belong maybe to the ISP, internet service provider, like TNT, for example, or um, uh, um, yeah, so something like that. And then the router, which belong to ISP, will route the information. For example, go to GSU, assuming this is the GSU. Here, they're assuming this yellow box is GSU. So in GSU, they will have another local area network that connect multiple machines together. So for example, this may be your laptop. When you connect to the you connect to GSU network. This may be some server. This may be another computer in some lab, and all of these are connected together via another local area network. So for example, let's assuming that iCollege is stored on a server, dedicated server inside GSU. Then from home you connect to the internet. You will go through multiple router, and finally you go to GSU and you connect to a machine in here. So now we already discussed the internet and the local area network. Now let's talk about another type of network. Is called a wireless mobile phone or cellular network. So for example, you may have a smartphone, and the smartphone will not connect to a LAN but will connect directly to the ISP. So for example, the ISP may be AT&T. They have a base station that placed near your place. So for example, if you are staying at home, you access the smartphone will connect to a base station, which is a tower that placed very close to where you live. And the base station is belong to ISP, and the ISP, they will transfer that information from the smartphone to the router, to multiple router via the internet. So for example, on your smartphone you connect to Google and search for some website. Then the information from smartphone connect directly to ISP will go to some remote server on the internet. That is the basic difference between a mobile network, cellular network versus a local area network. And in the end, we will have a multiple computer. Smartphone is a computer. Your PC is a computer, or GSU dedicated server is another computer. And multiple computer, they connect together, maybe locally like via LAN or uh, through the internet to connect to each other. Now we have already discussed about a hardware component. Now let's talk a little bit about software component. So we have two main category for software component. These are applications and operating system. So for applications, there are plethora of them. There are many kind of applications, but we will focus on operating system because operating system is what we are gonna learn on the first half of this semester. So let's look at this graph. This will be much easier to have a overview about the OS. You can see here the user is you, for example, and you connect with the software, the whole software system. Now, most of the time you work with an application program. So for example, right now I am using a slide reader like PowerPoint or PDF, for example. This is an application program. So for example, if I click the button here, like click like this, it changes the screen to another slide. Then actually I issue a command. So for example, I click next. The application will interpret my command next, and it will send a command to the OS. So everything below here belongs to the OS. From right here is this is the OS. So the program, they interpret my command, they send another command, and this command is called API or application program interface. So an API send it here, and the application programming interface is a module. It have the job is to interpret the command from the application program. So application program send a command, is interpreted and change it into a specific signal sent to kernel. Now here is kernel is a main component of the OS. Okay, it receives that specific signal. Maybe it will do some specific thing. So for example, in my case, when I click on this next button, it may issue some command to the file management system to read the next slide that I'm gonna read. Then it might issue another command to the driver to ask the monitor to display the next slide for me, for example. And then after that, it will return a final signal back to the application program saying a success or something, and so on. So you can say that the operating system will manage almost every and all the complicated stuff below, and the application program will use the system by issuing a API command. So again, the this whole thing here belongs to the OS, and we will have something like the kernel is the most important part of the OS. It's a core component, and it will have to interact with all the hardware, and it also have to interact with the application program. This is just an overview of the whole system. So let's talk about a specific software category in a Unix system. So in a Unix system, we will have multiple subcategories. At the highest level, we have a software. Then we can categorize it into application software and system. The system, now we will have two main categories. It is a utility, and we have operating system. The operating system obviously is a big guy. It's manage almost all the complicated stuff, but you also have something like called a utility, which is a very specialized application. So for example, utility like a disk utility. So for example, your OS is broken. You have to use a utility to to start the machine in another mode, and you have to use utility to read the disk, repair the disk, or so on. It's a kind of utility. But for the old operating system, we will have another multiple category. For here, we have the kernel and the shell. The kernel, as you can see here, the kernel here is a core component of the system, and we have all types of arrow point to the kernel because it's a core. It will interact with other components. But here we also have another thing called a shell. So the shell is a program that helps you, the user, to interact with the operating system. And the shell should be something right here, is in the application program. So the user can interact with the shell, and the shell will interact with the kernel and have the kernel manage all the have the kernel to do all the complicated stuff here. So the user, they have two choices. They can interact with the shell, which is also the kind of interface to interact with the OS, or they can interact with the application program. So we have here shell and kernel. Now, as you can see here, this paragraph saying that the operating system is handling almost every and all the activities of the machine, not just handling, controlling, it will oversee the operation of all the components. So for example, it will store and receive the files, access the network, almost everything. And it will do some other stuff like schedule the program for execution. How is that? We will discuss that on the process. It should be on the later part of our courses. And then it provide a user interface to the computer, like how to click on a button on the screen. That is the kind of interface that OS have to handle. And the operating system manage the resources like CPU and memory. So for example, you have 8 gig of memory. How to use it? You give the memory to the OS. The OS will use and handle everything for the memory. So you don't directly use any hardware, but you have to ask the operating system to use it for you. Then we have another category is the application program. It's a generic term for any other kind of software except the OS. Like as we discussed before, we have the word processor, well, games and missile control system. Well, that is true because missile control system is an application software. And finally, we have like most operating system and application program will have graphical user interface. Okay, that is very easy. When you open the Mac or Windows, you have some option like double click on a folder. You open the folder, you open the file, then everything you can interact with via mouse clicking, and yeah, so it's basically a graphical user interface. Now let's talk about the shell. So we have already discussed the shell for several times. So what actually is the shell? The shell is a program that helps you to interact with the system. So the shell is not the graphical user interface. The shell is more special than that. So for example, I'm open here a black Windows, which is called a terminal. So for example, I type in a command called ls. This command will show all the kind of folder in the system. So I just interact with the OS. What did I do? I just ask the OS to open all the folder in the current system, and then list to me the name of all the folder on the disk. So how I do that? I interact with the shell. So where is the shell? The shell is actually a program that have that black screen. And this black screen is not a graphical user interface because I have to interact it with via command, like ls is a command. Okay. So GUI or user interface is more like this Windows. So this is my GUI. So for example, if I mouse click on a folder, it will show me all kind of software all file inside the current folder software. So I interact with the OS. I ask the OS to list all the files and folders for me, but via a mouse click on a folder icon. And this is totally different from this shell, which I ask the system via a command. So now back to the slide. Now you can see it more clearly now. The operating system is the ultimate unit to receive all the command, but the shell here is kind of the black screen that I use, and user here is me, and I interact with the shell via a command. And this is the arrow for issuing the command, and this arrow meaning it's returning some result to me. Now multiple users can interact with the same shell to interact with the one system. So for example, in my laptop, I can have multiple users that interact with the shell. Well, it can be hard to imagine, but in later example, you will know that it is possible for multiple users to interact with the one same shell to finally interact with one operating system. Now let's discuss on another important procedure that we need to mention is the booting process. So that means what is the process for the OS to start. Now first let's talk about the basic structure. We remember we have a main component of the computer system is the CPU, which is not shown here, and the main memory, which is here. The main memory, they have some kind of RAM or read-only memory. It has some thing called a bootstrap program, and we have a much bigger chunk of main memory is called volatile memory. Volatile memory means that when the power go off, everything will be erased. That's mean volatile. Now we have a secondary memory. It's called is it disk storage like the hardware hard disk, and the hard disk stores your OS. So for example, imagine the Windows is stored in here. Now when you push the power button, then the moment your power button is pushed, the bootstrap program in DROM will be ran. And what does the bootstrap do? The bootstrap will access the disk and read the essential portion of the OS and then load that OS to the volatile memory. That will be shown here. Then the bootstrap program will give the permission to execute to the operating system. Now it will give everything, it will handle everything to the operating system. And from now on, operating system will run on the computer system. Now let's talk about the Unix as a operating system. Now Unix is an operating system. That means just like any other operating system like Windows, its main job is to provide a framework for program to run and working with file. So for example, the Unix here is a framework for file system to run, for program to run, and to connecting with each other. So for example, you have a Unix, you have a word processing, you have a web browser, or you want to store something, like you want to store a file, you read a file, everything will be supported by an operating system, not just Unix, but any other type of OS. And everything is API. Now again, this is not just Unix, but also the same for Windows, Mac, and other types of OS. Mostly they use a API architecture. That means everything is system call. Now let's see this chart. The Unix here is the operating system, and it have a box, and this box is called API. It means application programming interface. Now every and all the other program must communicate with the OS via the API in order to do any and every other task. So for example, you have a Word document. So you want to open a file via word processing. The Word have to issue an API command to Unix. And the Unix will go to file storage to read the file, show to the monitor to you. So for example, if you want to use the black windows called shell to list all the files in your disk, then the shell will issue an API call to Unix. Unix will go to file storage, read it, and list the list of the file back to shell. Shell will show it back to you. For example, if you open the web browser, you Google something, then the web browser will be the user application. The web browser will issue an API call to Unix. The Unix will go to network and go to Google. It will fetch the website at google.com and then return the result to the web browser, and web browser will display to you. That means ultimately everything will work through the system call. And again, it's not just for Unix, but it's the same for Windows. Now let's discuss another concept, is the process. So when a program is executed, it is loaded into memory, and the thing in memory now is called a process. So let's have an example. I will open a system monitor. This is in the Mac, and it's the same with the task manager in the Windows system. So you can see here we have a process that is opening the slide. We have another process called Google Chrome because I'm opening a Google program. Now the thing in the task manager showing here is when it has been loaded from the disk to main memory and running in the system. This thing is called a process, and it's not a program. Okay, so here is process, here is process, and you can do the same with your own computer. Go to your Windows machine, press Ctrl down, and you will see a task manager, and you can see a list of process. So basically, process is a program that has been executed and loaded into memory. So most process read and write data from and to files. And process and file, they have an owner. So if you create a file, then you are the owner of that file. So if you click on the file to run it, so for example, you click on Firefox icon, then the process will have an owner, but the owner here is the process that you use to open the other process. Well, we will discuss this concept later. And Unix support hierarchical directory structure. That means that we will have a folder or directory inside another directory or folder. So for example, back to this screen, we will have here is, this is the folder or directory called software. Inside here I have multiple files, and I have another file called Eclipse, which is another directory or folder. And this is what hierarchical structure means. We have a folder inside a folder inside a folder. That is a hierarchical structure. And Unix provide capabilities for you to create, modify, and destroy files, programs, and processes. So that means that if you want to create, modify, and destroy a file or a program or a process, then you have to ask Unix to do it. It's the same for Windows. If you have to do anything, you have to ask Windows to do it for you. Now here is some attributes for Unix, that is sharing the resources like CPU or memory or disk. That means multiple programs can reside and live peacefully together in the same machine, sharing the hardware. So for example, let's look at the task manager. Here in the Mac, you will have here multiple processes coexist peacefully in the system, like we have screen capture process, we have activity process, we have preview process. Each process will consume a certain amount of CPU. So for example, you see here screen capture use 23% of the CPU, but they don't use all of it. Same for memory. Multiple process, they will use a certain percentage of memory. And how could they do that? Of course, thanks to our system or operating system, it will help multiple processes to communicate each other and share the resource. Now, it also help the process to communicate with each other. So, for example, you can have a one process, one window communicate with another windows. Now it is not clear right now, but we can actually do that. We can somehow transfer data from one window, from one process to another process. Well, we don't go into the detail of that right now, but we will have a chance to do it later in the course. Finally, we have a utility. That is something that Unix will provide to you, and many of the utilities we will learn that in later lecture. Now is support for programmer. Support for programmer meaning that programmer need to compile the program. Programmer may need to process the data in parallel, or need to read and write a file, or communicate between processes. Everything can be done in our system. That is also the way that we will do it in the second half of this semester. That means that we will try to programming in C, because the C is supported by the Unix. Now we talk about the advantages of Unix. Again, many of these properties is common between operating system. Windows have it, Linux have it, Mac have it. So by saying advantages, is it advantages compared with an older operating system? But this is advanced because it's different from the one we have in the past. So for example, multitasking, like you can at the same time open the slide, but you can do like listen to music on the same time, or you can even browsing the web at the same time. In the past operating system, they cannot do it, but Unix and many later operating systems can do it. So that's why it's called an advanced attribute. This can support multiple users, so you can create multiple accounts. For example, one to you, one to your wife and your brother, for example. That means multiple people can share resources on the same computer and to work independently. It is safe because the process and program are separate from each other, and each have its own memory and storage. So for example, the music program and the web browser, they share the memory and storage, but they will not steal the resource from each other. Web browser cannot take some memory from the music program to its own, or write data to the file that is currently processed by the music program, as this is called a save. Now, again, Unix is kind of a family of the operating system. So we have many versions of operating system. Like at the beginning, you have something like a Unix, and then you have go through multiple versions like 5th, 6th, and 7th edition, and then it began to branch. It will branch to BSD family, including the Sun OS, Utrecht Next Step. This is the one family of the OS. Then we have another family of the OS here like SVR5, HP, AIX, and then again it belongs to another branch. That all of these belong to the same Unix system. That's why we say that Unix is a very popular operating system.